Good morning, class 9C. In our last class, we completed the numerical based on Charles' law. Now we have left with one type of numerical, that is the gas equation, which is a relationship between pressure, volume, and temperature. That means if if the pressure and temperature is not fixed, how the gases behave, that will be studied under the gas equation. Okay. Now, first we'll derive the gas equation. After that, we'll be doing the numerical based on it. So gas equation. Okay, so we'll try to derive the equation. So according to Boyle's law, we know that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. So we can write V inversely proportional to 1 by P. And according to Charles' law, B is directly proportional to T. That means the volume of a given gas is directly proportional to its absolute temperature. Now, on combining these two, okay, on combining these two equation, we can write V directly proportional to 1 by P into T. Okay, 1 by P into T. Now, when you remove this proportional sign, we can put constant. So 1 into T is T by P, and when you remove this proportional sign, we put constant. Let that constant be we keep at constant only. Now if we just make an arrangement, this P will go and multiply V, it becomes PV, and this T will come down, okay, which is equals to constant. Now accordingly, if the volume of a given mass of gas changes from V1 to V2, its pressure from P1 to P2, and its temperature from T1 to T2, then we can write P1 V1 by T1 equals to P2 V2 by T2. So this is the final expression, which is commonly called as gas equation or mathematical expression for gas equation. This equation is also used for calculating changes in a gas volume when both its pressure and temperature changes. So this is a gas equation. So this is how we derive the equation. P1 V1 by T1 equals to P2 V2 by T2. This is gas equation. We need to remember this equation for our numerical. Now there is a term called standard temperature and pressure. In short, we call STP, or we also call NTP, normal temperature and pressure. Now what is the standard temperature value? Standard temperature value is 0 degree Celsius, and in Kelvin it is 273 Kelvin. And standard pressure is 76 centimeter mercury, or in millimeter it will be 760 millimeter mercury, or it will be 1 atmosphere. Remember this value of a standard temperature and pressure, because while doing the numerical we'll be using it. So today's question is assignment 11. What is a gas equation? Okay, what is a gas equation? Derive the mathematical expression of gas equation. So just now we have seen the derivation of mathematical expression of gas equation, so you'll derive it. And what does STP stand for? And lastly, write the values of its standard temperature and pressure. So complete the assignment and send it in my mail.